So we're all familiar with the equal sign, I would assume, and it is a very important tool in math as it represents equality. And what I mean by equality is just that the expressions or sets of values on both sides of the equations have the same value. So, for example, if I have the very simple equation 1 plus 1 equals 2, the values on either side of it have the same value. 1 plus 1 has the same value as 2. It's balanced. And we can use that balance idea to open up another use for, or analogy for the equal sign, and that is of a balance or scale of sorts. So if I use 1 plus 1 equals 2 and draw that on a scale, place 1 plus 1 on one side and 2 on the other, that scale would be balanced if the 1 plus 1 and 2 represented weight. But now if I subtract 1 from the 1 plus 1, if we simplify that, that is just combining all those numbers to just be in one singular number. If I simplify that, that just is 1. And now the scale would be unbalanced because 1 and 2 are not equivalent. They do not carry the same value. But now, if I subtract 1 from both sides of the equation, so I subtracted 1 over here, but if I also subtract 1 from 2, then this would be balanced because 2 minus 1 is 1, and 1 equals 1 is always true. But you'll notice that I subtracted 1 from both sides. So as long as the initial equation is balanced, 1 plus 1 equals 2. 1 plus 1 and 2 are balanced. As long as you do the same thing to both sides of the scale, it's going to stay balanced. It's like if you had the same number of gold bars on each side of a scale, and if you add or subtract the same number of gold bars, it's going to stay balanced because it's going to have the same number of gold bars and therefore the same amount of weight on both sides. So now in math, in pure math, we use equations instead of a scale analogy. But I do hope that that analogy better represented equality for you. So back to math. I'm going to write 1 plus 1 here. 1 plus 1 equals 2. And then I'm going to subtract 1 from both sides. And when I simplify, you're going to see that 1 equals 1. So that's obviously true. And we could even check to confirm that the initial equation is true, because the 1 plus 1 expression on the left side can be simplified to 2. So then we have 2 plus 2. So it's like if you just did that. So we know that that is true. And if we have this true statement, then as long as we do the same thing to both sides, it will stay true. So say we go back to just blank 1 plus 1 equals 2. Let's say I want to add 7 to both sides. So I'll have 1 plus 1 plus 7 equals 2 plus 7. And if we simplify these, we'll get 9 equals 9. And what you could actually just do is simplify the 1 plus 1 over here. So for this step, what you could actually do is just do 2 plus 7 equals 2 plus 7. And you would just know that that's equal because it's the exact same thing on both sides. So it's automatically equivalent. But I want to branch off from equality for just a second to talk about the unknown. So say we have a new equation, 2 plus 7 equals x. And here, x is a variable. And in math, variables are letters that represent an unknown value, like an unknown number. And whenever you see a variable, you always want to solve for it. And that letter, and it can be any letter, but I'm usually just going to use x, as that's the most commonly used general variable. I just want to talk about some notation with variables, and it's mostly how you're going to write that you're using the multiplication operation. So you really shouldn't use the cross symbol for multiplication. So let's say I want to do 3 times x using the cross symbol. That's going to get confusing because you have a whole bunch of cross-shaped symbols that mean different things. So I usually just use a dot like this if I want to use instead of the cross sign. Another thing that you can do is use parentheses. So I have 3 and then 4 in parentheses. It's in parentheses and there's nothing in between the other number and the parentheses. So that indicates multiplication. And lastly, if there's a number right next to a variable, that means multiplication. So if I write 3x, that means 3 times whatever the quantity of x is. And then just one other thing for division, I might use fraction looking notation. So say I have 18 thirds equals 6. I just 18 divided by 3. So I might use fraction looking notation for that. And that's kind of how those symbol operations are going to look for you for the rest of your path through math classes. So I'd highly recommend that you get used to seeing them like that. But those are really the only differences. So we can go back to variables now. So if we have 2 plus 7 equals x, and x is unknown, it's really easy to find the value of x because the x is isolated. And what that means is that it's just by itself on one of the sides of the equation here. So all we have to do is simplify the other side of the equation to find x. So if we do that, simplify 2 plus 7, we get 9 equals x. So the value of x is 9. And the reason that x must be 9 in this specific equation is because 9 is the only value of x that makes that equation true. If we bring back the scale and have 2 plus 7 on one side, and we know for that scale to be balanced, the other side must be 9. So if you had 2 plus 7 gold bars on the one side and you wanted to balance that scale, you would have to have 9 on the other side if you just visualize that scale. And that's really what solving equations is all about. You want to try and find the value of a variable to make the equation balanced. So that's, you're solving for the variable so that your equation will be balanced. But what happens when the variable is not isolated? So let's have the equation x plus 3 equals 5. Now you could probably look at that right away and know for that to be balanced, it would have to be 2, because 2 plus 3 is 5. So you could just look at that and know that x equals 2, because it's a very basic math fact that you've probably memorized. But you're not always going to be able to look at an equation and just know what the variable is. Some equations get very complicated. So that's why we're instead going to use properties of equality to solve for x, even in this very simple equation. So when you're solving an equation, the ultimate goal is to get x alone on one side and whatever value x is on the other, like x equals 9. The x is on one side and 9 is on the other, its value. So that means every step you take in solving an equation should be making the x more and more isolated until eventually it is by itself on one of the sides of the equations. So in x plus 3 equals 5, the x is obviously not isolated. It has a 3 over with it. And that 3 is being added on to the x. And the way that we're going to get rid of the 3 is just to do the opposite operation. So just how like 1 plus 1 minus 1 is just 1. If you visualize it on a number line, it's 1 plus 1 minus 1. You're just going back and forth. So those 1s would just cancel because they don't matter. They're just inverting each other in a way. So in the same way as 1 plus 1 minus 1 is just 1, x plus 3 minus 3 is just x. Those 3's cancel out. But if you recall from earlier, what we do to the one side, we must also do to the other. So if we have x plus 3 minus 3 equals 5 minus 3. And the 3's on the left would cancel, as I said earlier. So now you just have x equals the quantity of 5 minus 3, which is 2. So x equals 2. And 2 is the only value of x in that equation that will make it true and balanced. And you're probably thinking that I've greatly overcomplicated what could have been a really simple mental process. But for more complicated equations, like the ones I'll show in the next Algebra 1 video, this process is the only way that you're going to be able to solve for x. And the process becomes very fast if you have a lot of practice, so it wouldn't take you this long to solve a problem like this after lots of practice. I'm now going to show you an example with multiplication and division. So say we have 2x equals 8. And again, you could probably tell right away that x equals 4, but we're going to use the properties of equality here. So 2x means 2 times x, and the opposite operation of multiplication is division. So I'm going to divide 2 from 2x. And just like if you multiplied 6 by 2 to get 12, and then divided it by 2, you'd just be back at 6. 6 times 2 divided by 2 just equals 6. So those 2's cancel. And the same thing is going to happen here. I'm just going to divide 2 from 2x so that those 2's cancel. And I'm going to write it in fraction form here. So those 2's would cancel because of the properties of fractions here. So now that's just x. And then you have to do the same thing to the other side. So you can do that, and you have 8 halves, or 8 divided by 2, which is just 4. So x equals 4. And 4 is the only value of x that balances that equation. So there's just a couple of practice examples there. I'm now going to write a couple of practice problems on the board, and you can pause the video to see if you can solve them. So I'll write these. We have 6x equals 18, 7 plus x equals 15, x fourths equals 3, x minus 8 equals 2, and 4x minus 3 equals 8. So pause the video and see if you can figure these out. I'll give you 5 seconds to pause the video. Okay, let's work through these one by one here. So 6x equals 18. It's 6 times x, so the opposite of that is division. So you're going to divide 6 from both sides. 6's cancel. You have x. 18 over 6 is 3, so x equals 3. Seven plus x, equals 15. It's plus, however, you can see the x is modifying the 7, but you can just rewrite this as x plus 7 equals 15 if that confuses you. And then it's plus 7, so you're going to do the opposite of that. So that would be subtraction. So you're going to subtract 7 from both sides. Those cancel to have x. And 15 minus 7 is, is 8. So x equals 8. And then x over 4 equals 3. So it's division here. So the opposite of that is multiplication. So you're going to multiply 4 to both sides. So those cancel. That equals 12. So x equals 12. X minus 8 equals 2. It's minus 8, so you're going to do the opposite, which is plus 8. So you're going to add 8 to both sides. Those cancel. That's 10. 2 plus 8 is 10. So x equals 10. The last one is a multi-step equation. So you're going to need to do multiple steps in order to find x. 4x minus 3 equals 8. So you want to isolate the x. You're going to have to, to align with the order of operations, you're going to have to do the multiplication and division last. So you're going to do the addition and subtraction first. And it's just you work backwards through the order of operations. PEMDAS, if that's the abbreviation you learned. That's the abbreviation I learned, at least. So from the 4x is being subtracted by 3. So you're going to do the opposite of that, and that's to add 3 to both sides. So so you have this, because those cancel, and these equal 11. And then now you see you have the 4 here. So that's multiplying by 4. So now you would divide by 4 on both sides. Those cancel. And here, if you can't simplify the fraction, then don't, if you want to put it in decimal form, you can, but you can just leave it as 11 fourths. So x equals 11 fourths here. All right. I think that's it for today's video. The next lesson will continue with solving equations, mostly with multi-step equations, and that'll probably be out in a week from this video's release. I hope it could be of help, and thank you for watching.